This lesson is about the overall mechanical properties of a steel fiber reinforced concrete. Given that a huge amount of information is available in the internet, the lesson has been prepared with specific examples performed in our laboratory with the aim of clarifying the most relevant characteristics of a steel fiber reinforced concrete. The overall advantages of a steel fiber reinforced concrete mainly rely on its standing properties in terms of structural capacities, ductility, and toughness. It is worth noting that the use of steel fibers has an additional advantage, which is the wide knowledge in the field with more than 50 years of experience. Steel fibers reinforced concrete, as any other material, has its weak points that could be summarized in corrosion of steel, effect on the workability, or equipment wear or safety in handling. One standing possibility with a steel fiber reinforced concrete is to use self-compacting concrete as matrix. A remarkable increase in their residual strength takes place due to the improvements in fiber positioning as a consequence of the flux of self-compacting concrete. Nevertheless, the affection in the fresh state of rigid and stiff fibers might be important. That is why the following example includes some notes about the combination of self-compacting concrete and steel fiber reinforced concrete. That is to say, we will compare steel fiber reinforced self-compacting concrete with various dosages to assess the influence of steel fibers in fresh and hardened properties of the concrete. One mixture was manufactured with 50 kg per cubic meter of 35 mm long steel hook fibers, and another one with 70 kg per cubic meter. In another mixture, the two types of fibers were mixed in equal weights up to 70 kg per cubic meter. The two types of hooked end steel fibers chosen mainly differing in the fiber length and therefore in the aspect ratio. Also, the number of fibers per kilogram changed. The overall properties of the fibers can be seen in the slide. Tests for the adjustment in the fresh state of self-compacting concrete are unavoidable. In this case, tests with 60 kg per cubic meter of the short steel hook fibers were performed, and having some initial problems as shown in the slide. The addition of these fibers produced a reduction of the slam flow spread in 50 mm and a poor distribution of fibers and aggregates were found. However, by modifying the aggregate proportioning and the content of superplasticizer, it was possible to achieve the desired results. As can be seen in the slide, with all the mixtures produced, it was possible to assure self-compactability. By way of example, the slide shows the mixed proportioning of the mixes in which moderate contents of cement, limestone powder, and admixture were used with successful results. The graph shows how the addition of fibers affects the results of compressive strength. Note that even this property is the most representative for conventional concrete. In the case of fiber reinforced concrete, the influence of fibers is limited, showing slight increases. However, the mode of failure is completely different from that of plain concrete. The plain concrete specimens fail with the typical brittle fracture and a broad mode, while the specimens with fiber show a very smooth fracture without any mass loss. With regard to the values of elasticity modulus, the results show no clear trend, and only minor differences were obtained. In the case of the tensile splitting strength, the figure in the slide showed that the presence of fibers raised the indirect tensile strength. Such a strength of the high fiber content concrete, the increase might reach up to 80% compared with the plain concrete. This indirect splitting test might provide such improvements and also show the different mode of failure. Nevertheless, it's worth noting that it is not the appropriate test for fiber reinforced concrete. Second-order effects occur during the test in fiber reinforced concrete, and thus notes and conclusions can be deduced. In conclusion, mechanical properties are improved compared with those of plain concrete, although compressive strength, elasticity modulus, and splitting test do not provide enough information in order to consider fiber contributions. All the mechanisms associated with the tensile stress are remarkably improved, That is why fracture tests are needed in order to evaluate the contribution of the fibers in structural design. Moreover, fresh state is affected by the addition of steel fibers, which are rigid and stiff, though it is possible to achieve self-compacting properties even with important amounts of steel fibers by means of superplasticizers and slight changes in the mix proportionate using steel fiber reinforced concrete. Thank you for your attention.